Hey kids, this is Mr. Cozy and this is video 29 where we start a small unit on solving quadratic equations. Recall that quadratic means that x is squared, so we are solving equations where x is squared. Today we are going to focus primarily on solving using inverse operations. So let's look at that, and yeah, let's go. First example is x squared plus 3 equals 7. Now, the idea of solving using inverses is that you take whatever it is squared and isolate it, get it alone, so that you can take a square root. So in this case, I would do something like minus 3 minus 3. That would give me x squared equals 4. And then with this x to the second isolated, I can take a square root of each side. That because square roots and squaring are inverse operations, that cancels out the exponent, and I'm left with 2. Now remember, guys, that whenever you add a square root to a problem, whenever you add it, it's plus or minus. So this actually has two answers. X could be positive 2 or negative 2. Okay, let's take a look at something else. Let's take a look at 3x squared minus 8 equals 16. Okay. Once again, I want to isolate the thing that it is squared. So in this case, I would add 8 to each side, and then divide each side with 3. Oops, it's not 16, that's 24. There we go. And I would get that x squared is 8, and then I can take a square root of each side. Now once again, guys, it's plus or minus, and I really need to simplify that radical. Okay, 8 is 2 times 2 times 2. I can take 2 of these 2's out from under the radical. This 1 2 gets left in the radical, so I get plus or minus 2 square root of 2. And that's my answer. Okay, let's look at another one. Let's look at 2x minus 1 squared over 3 minus 4 equals 16. Okay, once again, I want to isolate the thing that it is squared. Now in this case, that thing is a whole expression. That's okay. I won't let that upset me. I am going to push on with the problem. So okay. Gotta solve for this thing that is squared. So plus 4 plus 4. I'm gonna get 2x minus 1 squared over 3 equals 20. Times 3 times 3. So I'm going to get 2x minus 1 squared equals 60. And now I can take a square root of each side to cancel out that squared. 60 is 2 times 2 times 3 times 5. Those are the prime factors of 60. I can take 2 of these 2's out and leave the 3 times the 5 under the radical. So I'm going to get plus or minus 2 radical 15. I'm going to need a little more room here. So I have 2x minus 1 equals plus or minus 2 radical 15, plus 1 to each side. Now guys, very important, these are not like terms, so I have to keep them separate. 2x equals 1 plus or minus 2 radical 15. Divide by 2, divide by 2. X is 1 plus or minus 2 radical 15 over 2. Now there's a few ways that I could write this. This is fine, but if I wanted to, I could break it up into 2 separate terms. And that lets me do a little bit of cancellation so that I end up with 1/2 plus or minus square root of 15. Okay. Now, I just kind of blew through these examples because all of the operations that I used, I basically used the same strategy that I would have used if I wanted to solve something like 3x minus 6 equals 10. Okay. I can use inverse operations here to isolate the x, so that the x is alone, and then I have my answer. It's the same idea with these other examples. The only difference is that the thing that I am isolating is not x. It's something that it is squared, and I'm isolating it so that I can take a square root of each side. That's what happened here. It's what happened here, and it's what happened here. Now, this is different because after the thing that was squared was an expression. So once I isolated it and took a square root, I had more to solve. But what I'm trying to impress on you is I'm using the exact same tools that I would use to solve a simple linear equation like this. It's just that sometimes things are squared, and I need to I need an extra tool in my toolkit, namely taking a square root to handle that. The one last thing that I want to point out, and this is something that I expect you to be able to talk about with me tomorrow. I want you to take a second and look at these 3 examples. Here was our previous example, the one before that, and the one before that. Okay? All of these I solved using inverse operations. On the other hand, an equation like this, I could not solve using inverse operations. The method that I just showed you won't work in this case. I need to use some other method. The question that I want you to think about, and we will talk about tomorrow, is what is different about this equation from all of these other examples. what thing about this makes it so different that I couldn't solve this equation using inverse operations. Okay? Okay, I'm going to wrap this up right here. Have a great day, and I will talk to you later. Goodbye.